aside and see what we can learn from skeletal remains and how. First, when we are young children, we have about 450 bones, but those bones start to fuse and join together. So as an adult, after we're fully developed, we have about 206. In younger skeletal remains, we can use these numbers to help us determine the age. I'll talk more about age a little later. What else can bones tell us? Children build bones faster, and bones grow in size. After about 30 years, that process is reversed. Bones break down, they start to shrink. So the number of bones, as well as their condition, can tell us a person's age, their health, and the amount of calcium they had in their food. Bones tell us a lot. Some things that we can see are loss of bone density, poor teeth, which can happen because they're not taken care of. It can also happen depending on your diet, and they just wear down over time. We can also see signs of arthritis. We can see any previous fractures, artificial joints and pins. We can even tell if a person is right-handed or left-handed. Their diet, especially vitamin D and calcium. We can also find diseases and genetic disorders, some just by looking at the bones, sometimes through bone chemistry or DNA. We can also see the type of work or sports they may have done based on bone structure, especially if they did something with manual labor, as muscle attachments and joints that see a lot of repetition. We can see that in the bones. We can also tell if an individual has had a baby. I want to talk about some easier things to identify. First, in identifying male versus female. If we have a full skeleton or close to it, we can look at the overall appearance of the skeleton. Males tend to be bigger, thicker bones. The bones tend to be rougher, more bumpy, and that's due to larger muscle connections. When a muscle is connected to the bone, because that's how they move, we get bigger ridges and bumps on the male skeleton just because they're overall bigger. Females tend to be smaller or slighter, and their skeleton appears smoother because of the less pronounced muscle attachments. We can also learn male versus female if we only have a skull, and that's because they are shaped very differently. For example, the frontal bone, which is your forehead, tends to go up higher and be more rounded on females, and it tends to be low and slope backwards on men. The shape of the eye socket, so where your eyeball sits, rounder on females, more square on the males. The temporal crest, which is kind of the edge of your forehead heading towards your ears, can be more visible or smaller depending on male, female. The mandible, which is your jaw, and it includes your chin. So if you're looking at the front of the skull and you're looking at the chin, male skulls tend to be more square, and female skulls tend to be kind of V-shaped. And lastly, if you're looking at the front of the skull, where our eyebrows sit, is what we call the brow ridge, and that tends to be thicker, more noticeable on a male skull, and smaller and not as noticeable on a female skull. Here I have a side-by-side male skull on the left, female skull on the right. I believe the most noticeable one is the chin. It's very square on the male one and kind of pointy and V-shaped on the female skull. Also, if you look at the side of the skull, there's some differences. Towards the back is what we call the occipital bone, and there's a thing that kind of sticks out. If it sticks out a lot, it's male. If it's not there, sticks out just a little bit, it's female. The surface of the skull tends to be bumpier on a male and smoother on a female. The mandible, again, your jawbone, from the side. If you feel straight down from your ear, you can feel the edge of your mandible. If it's kind of straight up and down at a 90 degrees, it's male. If it kind of slopes backwards towards the back of the head, it's usually female. And if you feel right behind your ear, there's a bump there. That's called the mastoid process. That tends to be larger on males and smaller on females. And here is a side view, male skull on the left, female skull on the right. You can see that very 90-degree jaw on the male, slopes back on the female. You can also see the mastoid process there as well. The other way that we can determine whether it's male or female skeleton is with the pelvis. So if we don't have a skull, or to confirm what we found with the skull, we can look at a pelvis. And there are some different angles, and I'll show you a picture in a moment. All of the angles on the pelvis tend to be wider on a female than a male. The overall shape of the interior, the big opening of the pelvis, is heart-shaped on a male, oval on a female. And the overall shape of the sacrum is a little bit different. That's what your spine sits on, what your pelvis is attached to. It tends to be longer, narrower, and curved inward on a male, shorter, broader, and curved outward on a female. And let me show you these in pictures because they're kind of hard to see. So here is the subpubic angle. On a male, it's more V-shaped. It's a tighter V. On the female, it's a lot wider. And then this is looking down into the pelvis. If you traced the shape, it's almost heart-shaped on a male pelvis, and it's pretty round or oval-shaped on a female. And then we also have the sacrum here. You can see how that kind of points into the middle on the male, and it's kind of back further on the female. And that, all of those things, the wider angle, the round versus heart, the back pointing sacrum versus the in pointing sacrum, are all because females have to carry babies and they have to fit through that opening. So everything's a little bit wider on the female pelvis. I mentioned that we can distinguish age by the number of bones and how they are health-wise, but we can also do that through suture marks and what doctors often call growth plates. So first are your suture marks, and these are kind of zigzags that you see on the skull, and that's where bones have fused together. Many of you know that a baby has a soft spot, and that is literally a hole in the skull where the bones have not fused. And gradually those will fuse together and it will harden and become bone. Those sutures will grow together, and those zigzags will start to fade as the person gets older. So we can use those sutures to tell us how old the individual is. For example, the coronal suture, which you can see in the picture there, goes across your skull, kind of right in front of your ears. That's the big one. That's where the soft spot is. It's not completely closed and faded away until you're 50. So if it's completely closed, we know the individual is over 50. The lambdoidal suture, which also goes across, but it's at the very back of your head, it begins to close at 21. So if we see that, we can guess the age of a person. It goes faster at 26, and it's closed by 30. So we can use those sutures to figure out how old an individual is. We can also use what are called epiphyses. And these are lines that form as cartilage is replaced by bone. And you see this at the end of a lot of bones, especially like your leg bones, your arm bones. You can see that in the picture there. Eventually, those two separate pieces will fuse together. The growth plate on the end will fuse to the long part of the bone. And we can use that, just like the sutures, to figure out how old an individual is. And each bone, we know, there have been lots of studies, takes a different amount of time to join together to fuse the end of the bone to the long part of the bone, so we can determine age. I have a couple charts here. I'm not going to read through them, but you can see that we can figure out ages. So for example, the arm bone, the humerus, is in your upper arm. That head fuses sometimes between 18 and 20. So we can see if it's not fused yet that they're probably younger than that. We can use leg bones, you can use the shoulder, and you can actually use parts of the pelvis and then the sutures in the skull like I mentioned. We can also, if we don't have a full skeleton, which we rarely do in the archaeological record, estimate the height of an individual based on some of their long bones, which again are the leg and arm bones. So we can measure those and compare them to known populations to determine about how tall an individual is. So there's some math in history as well. I want to mention before I move on that a lot of crime shows that analyze skeletal remains identify race, and that is very hard to do. It's almost impossible. They're basically making an educated guess based on past populations. So it's not very accurate, as race has no real biological basis. But sometimes we can get a good estimate. There are computer programs out there that scientists use. They take a whole bunch of measurements of the skeleton, plug it into the program, and the program will give you a probability of the race of that individual. The problem is those statistics that the program use are from past populations, so they don't represent current ones, and it's not far back enough that we can use it for our prehistory remains like we've been talking about. We can also do facial reconstruction, another thing you might see in those crime shows. We can build a face of a skeleton using clay. We do have to make some guesses about how deep their muscle tissue is, but we can usually get pretty accurate. This is used a lot for missing persons today, but scientists use it for past populations to see what different hominid groups, different ancestor groups actually look like. We can also extract DNA from a lot of bones, even when they're really, really old. Teeth are actually a great place to get usable DNA. And we can extract it and compare it to living populations as well as go back in time. The last thing I want to mention is skeletal trauma analysis, which is, again, another thing that you see on a lot of those crime shows. We can look at the skeleton, and like I said, we can find out bad things like diseases, but we can also see if they suffered any injuries, because once you fracture a bone, the evidence is already there. It always will be, even if it's healed. So forensic scientists can look at these marks and determine what happened to an individual. For example, we have a blunt force trauma to a skull there. In the bottom one, we actually see someone that was shot. Those are rib bones that have bullets in them, but they survived because the bullets have healed into the bone. So there's a lot of things that we can find out from skeletal remains. And I want to demonstrate kind of how you do this. We have a skeletal model down in our science lab, so I'll walk through what I found out about that individual. Hello, I'm Miss Westland. You've been hearing my voice up until this point so far, but I just wanted to demonstrate how we are able to use some of the things I just talked about with skeletal remains to actually make some identifications. Very rarely in the archaeological record do we find a complete skeleton like I have here, which is down in the science rooms here at Roz. But we can tell a lot of things from just parts of bones. So I want to start at the top and we'll work our way down. So here we have a pretty complete skull, and we can tell lots of things from the skull. Identifying if it's male or female is one of the first things that we can do. And then looking at this skull, I will tell you that it is a male, and I can tell that for a lot of reasons. First, its chin right here is very square shaped in the front, which indicates male versus female. On the side here, this angle here, which is your jaw right back here under your ears, if that is pretty straight up and down, it is also male. If it slants a little bit back, it's usually female. Also, we have the forehead here, all right? The kind of straight, more rounded it is, and kind of goes up and back. It is more female. It's a little more sloped on a male, all right? And then this bone right here, which is called the mastoid process, it's that really big bone you can feel right behind your ears. Those tend to be small on female and large on men, and so this one is pretty big. The last thing I'll have you look at are the eye sockets here. If they're kind of square shaped, and they actually feel kind of rounded here on the edge, they are male. If they were more round with a sharp edge, they would be female. Because I have a skull and a pelvis, I can also verify that this is a male, because this pelvis tells me it's also a male. And again, for quite a few reasons. If you look down into this big opening here, on a male it's kind of heart-shaped when you trace the whole thing. All right? On a female it's more rounded because a baby has to go through there. All right? Also, there is an angle here under the pubic bones. If it's very narrow like this, it's a male. If it's spread out, it is female, again, because babies have to go through there. All right? There is also this notch back here. It kind of falls below your spine and your sacrum. If it's wider, it's a female. If it's narrower, it is a male, and this one is pretty narrow. All right? So both of those things tell me it's a male, so I would say that this is a male skeleton. All right? Sometimes you do get contradicting things, and you might have to look in other areas like measurements of the bones. The younger the individual is, the harder it is to determine male or female, because younger individuals will have a lot smaller things, so those larger versus smaller don't work out because they're small for everybody. All right? Some other things we can determine are height. If you had a complete skeleton, you could just measure the height. But again, in the archaeological record, we aren't able to do that very often. We find bits and pieces. So if we have long bones, like the ones in the arms and the legs, we can measure those and determine the approximate height of an individual. All right? So if I just had the femur, I could measure and see how tall they are. Right? Or if I just had the humerus, I could do the same thing. Another thing we can look at is age of a skeleton. Because this is a model and not a real skeleton, a lot of the age characteristics are actually really hard to see. But this is a younger individual, probably in their 20s, and I can tell you that for a few reasons. One is the ends of the long bones here are not fully fused. I can still see a line between the long part of the bone and the end. All right, and I can see that in a couple of different places. All right. I can also see that they're younger because they don't have their last molar, which makes me think they're early 20s. But depending on when the skeleton is, they might have been pulled. So that might not work because, it's a model. I can't tell if it was there and removed or if it just hasn't erupted yet. All right. We can also look at different things and find out how they ate. If their teeth are really worn, they would be for hunter-gatherers. We would know that they ate hard things like seeds and unprocessed grains. These ones look pretty well intact and not very worn, so I would say that they're not from an old population, they're from a newer population because we take care of our teeth and we eat more processed foods, which is a lot softer and doesn't wear on our teeth as much. All right? I do have a few. I'm going to step out of frame here. Examples of I do have an example of a female pelvis, so you can kind of see the difference of what I was talking about here. This one, if you trace the shape, it's round because the baby has to go through. We also get the wider notch here, all right, because the baby has to go through. All right, and then the last notch I was talking about is right here. It's very wide on a female pelvis. It's a lot narrower on the male pelvis in the back there. So hopefully this shows you that we can see a lot from different skeletal remains. This one doesn't have any, but there were the other things we talked about in the PowerPoint a moment ago. We talked about skeletal trauma, so we could see if there was anything wrong with them, maybe cause of death. We would be able to determine age more accurately on a real skeleton. And we would also be able to do genetic testing to find out certain things that they ate, We could also follow the maternal DNA and see who their ancestors were. We can find a ton about past populations without any sort of written record through artifacts and things like skeletal remains.